Hi, everybody. It's Professor Mitchell, continuing with Chapter 1. Today, we're looking at Section 1.2 on the slope of a straight line. In this section, we'll look at the slope of y equals mx plus b, an alternative definition of slope, the steepness property, the point-slope formula, the perpendicular property, and the parallel property. All right, so as you probably know, for the line given by the equation y equals mx plus b, the number m is the slope of the line. All right, so here's an easy example. We'll find the slope of each of the following lines: y equals 6x minus 9, y equals negative x plus 4, y equals 2, and y equals x. All right, so the first one, remember, just match each equation up with y equals mx plus b and try to identify the number m. So for the first one, m is 6. For the second one, m is negative 1. Think of this as negative 1x plus 4. For the third one, m is actually 0. Notice that you don't see an x term over here, so you can think of this as y equals 0x plus 2. And then finally, m equals 1, because you can think of this as y equals 1x plus 0. All right, and then the alternative definition of slope. This is actually the reverse of what I usually do in an algebra course. I start with this definition, and then we actually show that the slope of y equals mx plus b is m. All right, so the alternative definition of slope: if L is a line passing through the points x1, y1, and x2, y2, where x1 does not equal x2, then the slope of the line is given by the formula m equals y2 minus y1 divided by x2 minus x1. In other words, the difference in the y's divided by the difference in the x's. All right, so in this example, we'll use the alternative definition of slope to find the slope of y equals 6x minus 9. I don't mind telling you that this is not normally the way I would find the slope of y equals 6x minus 9. All right, so what they're doing is they're finding two ordered pair solutions for this equation, sort of like we did in the last section when we made the table, when we were graphing the line, starting with x equals 0, and you can really use any value of x here. Then the corresponding y is 6 times 0 minus 9, which is negative 9. So we'll make x1, y1 be the point 0, negative 9. Now we'll pick another value of x, say x equals 2. Then y would be 6 times 2 minus 9, which comes out to 3. So x2, y2 will be the point 2, 3. And when you plug those 2 points into the slope formula, you get 3 minus negative 9 divided by 2 minus 0. 3 minus negative 9 is 12. 2 minus 0 is 2. 12 divided by 2 is 6. Of course, we already knew the slope of this line was 6 just by matching it up to y equals mx plus b. So what I usually use this formula for is to find the slope of a line through two given points. All right, so they haven't given me the equation. They've just given me 2 points that are on the line. I'll use this formula to find the slope of that line. All right, next, we have the steepness property, also known as rise over run. If the line L has slope m, and we start at any point on the line and move 1 unit to the right, then we must move m units vertically in order to return to the line. Remember that if m is positive, we move up, and if m is negative, we move down. All right, so let's use that property to graph this line. I'm going to go over to the tablet. All right, so we have y equals negative 4x plus 3. I'm going to start with the y-intercept, which is 0, 3. That's this point right here. Okay, and then what they call the steepness property says every time you move 1 unit to the right, you're going to move m units vertically. So I'll go 1 unit to the right. And then since m is negative 4, that means I'm going to move 4 units down. 1, 2, 3, 4. All right, now if you're familiar with rise over run, I want you to feel comfortable using that too. The way that works is you set m equal to rise over run. And since m is negative 4, we'll make that negative 4 over 1. And you would get the same thing. It's just that usually I rise before I run. And so if I go 4 units down and I go 1 unit to the right, I end up at the same point. Okay. All right, so now we will draw a line through those 2 points, and that line will look something like this. All right. Back to the presentation, where we'll see their solution. It should look just like mine. Of course, the graph is a little neater. All right. Okay, that brings us to the point-slope formula. The point-slope formula is what you get when you take the slope formula and just clear out the fractions, okay? The equation of the straight line through the point x1, y1 and having slope m is given by the equation y minus y1 equals m times x minus x1. Remember that in any given problem, x1, y1, and m will be specific numbers. The equation will usually have the x and the y left in it. All right, so for the next example, we'll find the equation of a line that passes through the point negative 1, 4 with a slope of negative 3/5. Going back to the tablet. All right, so in this problem, x1 is negative 1, y1 is 4, and m is negative 3/5. So using our point slope formula, which is y minus y1 equals m times x minus, let me try that again, m times x minus x1. All right, I will substitute negative 3/5 for m, and I'll substitute negative 1 for x1, and I'll substitute 4 for y1. That gives me y minus 4 equals negative 3/5 times x minus negative 1. All right, so in problems like this, you typically need to look out for double negatives and fractions, and I have both of those things going on here. First, let's change that y minus negative 1 to, I'm sorry, that x minus negative 1 to x plus 1. Next, I will distribute the negative 3/5. And that'll give me y minus 4 equals negative 3/5 x minus 3/5. And then the last thing I need to do is add 4 to both sides. This is where some people get a little confused. I know fractions are not everybody's favorite thing. Okay, I have y equals negative 3/5 x, and now I have to add negative 3/5 plus 4. right? So -3/5 plus 4, just like when you add any fractions, you need a common denominator. So think of this 4 as 4 over 1, and then multiply the top and the bottom by 5. All right, so what that'll give me is my original -3/5, but then I'm renaming 4 as 20 over 5. Okay, so now let me see. Do I have any space to write the answer? I guess I could squeeze it in up here. All right, so my final answer is going to be y equals -3/5 x. And then we'll combine our two fractions. -3/5 plus 20/5 is 17/5. And that is my final answer. And I think this might be a good example of showing you why I like to go to the tablet and do those problems instead of just always showing them to you on the presentation. Because if you look at their solution to this problem, they don't show quite as much work as I did. All right. So hopefully that's helpful. All right, next we come to the perpendicular property. Again, hopefully this is something you've heard before. I bet you have. When two lines are perpendicular, their slopes are negative reciprocals of one another. That is, if two lines with slopes m and n are perpendicular to one another, then m is equal to -1 over n. All right, so in other words, flip the fraction over and flip the sign. Okay, flip the fraction, flip the sign. Conversely, if two lines have slopes that are negative reciprocals of one another, they are perpendicular. So in this next example, we're going to find the equation of the line through the point -3, 5, that is perpendicular to the line whose equation is 2x plus 4y equals 7. Back to the tablet we go. All right, so there are a couple of big steps to this. The first thing I need to do is find the slope of the given line. Okay. Sorry, my handwriting is usually not that messy. 2x plus 4y equals 7. So the easiest way to find the slope of this line is to solve the equation for y. So let's subtract 2x from both sides, which gives us 4y equals -2x plus 7. And then I'll divide everybody by 4. And that gives me y equals -2 over 4, aka -1/2 x plus 7/4. Now, the only important thing here for this problem is that the slope of the given line is -1/2. All right, so that brings us to big step number 2, which is to find the equation EQN of new line. Since the slope of the given line is -1/2, that means that the slope of the new line, okay, flip the fraction, flip the sign. Flipping the fraction gives you 2 over 1. Flipping the sign makes it positive. So the perpendicular slope is 2. All right, and now we'll use the Pointslope formula to write the equation of the line. So remember that goes y minus y1 equals m times x minus x1. M is 2, x1 is 3, y1 is -5. So we have y minus -5 equals 2 times x minus 3. Y plus 5 equals, let's go ahead and distribute the 2. That'll give us 2x minus 6. And when we subtract 5 from both sides, we end up with our final answer, which is y equals 2x minus 11. All right. Going back to the presentation for our last example. All right, so again, they did the same problem. They just didn't show as many steps. All right, that brings us to the parallel property. Parallel lines, as you have hopefully heard before, have the same slope. Conversely, if two lines have the same slope, they are parallel. All right, so this is the same problem we just did, except now we're finding the equation of the parallel line. Okay, the line that is parallel to 2x plus 4y equals 7, again, passing through the point 3, -5. Now, you'll hear me say this many, many times throughout the course, but whenever we come to a problem that you think you know how to do, please, please, please pause the video and try it, and then come back and compare notes with me, all right? You don't have to just watch me do every problem. I definitely like you to try some yourself. All right, so let's go over to the tablet. And I will assume that you have already tried this problem. If not, please pause the video, try it, and when you unpause the video, we will go over it. Okay, so now part of this we can skip because it's the same equation. The given slope is still -1/2. Okay. So the big difference in this problem is that we are not going to change that slope because now we're finding a parallel line. Okay. So once again, we will use our point slope formula, y minus y1 equals m times x minus x1. M is -1/2, x1 is 3, y1 is -5. So we have y minus -5 equals -1/2 times x minus 3. Changing the double negative gives us a y plus 5. Distributing the -1/2 gives us -1/2 x plus 3/2. And now I just need to subtract 5 from both sides. So this reminds me of, what was it, 2 problems ago? We get y equals -1/2 x. And now I need to combine these two fractions. So remember, think of the 5 as 5 over 1. This time we will multiply the top and the bottom by 2. So we get plus 3/2, and then instead of writing -5, I'm going to write -10 over 2. So my final answer will be y equals -1/2 x minus 7/2. All right, and that's how you do that kind of problem. Going back to the presentation, I just have one more little thing to show you, which is the graphs of those 3 lines. So here is the given line, and here are the 2 Here's the perpendicular line. Here is the parallel line. Here is the 0.3 comma -5. Okay. All right. So once again, I've got some audience participation problems. If you would like to try one or more of these problems and you're a student in my class, you can post those on the discussion board. All right, so summary. The slope of the line y equals mx plus b is the number m. It is also the ratio of the difference between the y coordinates and the difference between the x coordinates for any pair of points on the line. The steepness property states that if we start at any point on a line of slope m and move 1 unit to the right, then we must move m units vertically to return to the line. The Pointslope formula states that the line of slope m passing through the point x1, y1 has the equation y minus y1 equals m times x minus x1. And finally, two lines are parallel if and only if they have the same slope. And two lines are perpendicular if and only if the product of their slopes is -1. Now, this is different than how they said it earlier. I actually like saying it this way. The product of their slopes is -1. That is just a different way of saying that the two slopes are negative reciprocals. This is kind of a better way to say it, I think. All right. A lot of people like negative reciprocals, I guess, because it's a little more clear. All right. But that will do it for section 1.2. We'll see you next time.